Good morning. We'll start. In the last class, we were doing something related to Hadoop tools. So we will continue to do that in this class as well, right? The fifth module, which we are basically trying to talk about various Hadoop related tools. Some of the tools we have already gone through, and some of them we are just left with in the fifth unit. Right. In the last class, we had just gone through Hive and HBase, Cassandra. These are the technologies of the Hadoop related ecosystem that we had gone through, right? And the remaining set of tools that we are going to deal with today is the combination of Hive and HBase, right? As you already know, that Hive is a query language, right? And the query language is very well suited for database management systems, right? So in a Hadoop ecosystem, the database management system is a HBase, right? So the best suited Hive is HiveQL along with HBase. How does it basically work? Is what we are going to see in this particular class, right? So I'm just sharing my screen. Just give me a second. So meanwhile, the screen is up. I just wanted to stress about two important aspects, right? One is all of you please make use of the online opportunities. There are plenty of online courses which are available, which are offered free of cost by Coursera, Udemy, right? Then NPTEL and so many other places, right? I understand from many of your friends that you have not registered for any of these courses. Please do not do that, right? Please make a very good use of all these opportunities, right? They come to you once in a lifetime, right? For example, I just did 2 or 3 courses in Coursera, right? And they are all absolutely free of cost. You don't have to pay even a penny for it, right? And they are 4 weeks courses and 6 weeks courses which are available, right? You join any one of such courses which is going to be helpful for your mini project as well as which will be an add-on for your resume also, right? And do not sit idle like this, right? There are lots of if you go to BMS, if you log in from your BMS email ID and go to Coursera, it will automatically log you in, right? There is a registration link which was previously shared to you in your WhatsApp group. Hope you remember that. And using that particular link, you can basically register to any of the courses um, which are offered by Coursera. So please make use of such opportunities. I think in the last class we had just stopped at this particular slide. We had just completed with the previous one, which was on the MapReduce code for the data flow, which was for just a second, which was for actually the page rank, right? The page rank algorithm. So now we will be looking at the Pig Latin scripts, right? So the Pig Latin scripts are basically written in a Perl-like syntax. So as what you see on the page, right? You can observe that the Pig Latin scripts are there, right? You can see that the number of visits for each visit, what is that it is to be done, canonicalization of URLs, right, where the pages are loaded, right, and the page loaded is also indexed in the PageRank database. So you calculate the average page rank, that is the number of times a unique user has visited a particular page, divided by total number of visits. So that is going to basically give you the page rank, right? So you calculate the page rank in a Perl script kind of a thing, and you also calculate the average as shown here, and you also use the filters, right, where you are trying to find out the number of user page ranks which are basically greater than 0.5, right? So this particular user page rank, whatever that is being there, you basically store these page ranks into the store, right? And after you do the after you store it, right, you can basically retrieve the page ranks and display all those page ranks which are greater than zero point 0.5. So that is how you are basically calculating the page rank using a pig Latin script, right? And I just want to pause here for a moment so that you just take a screenshot of this particular slide. Although it has been shared on your Google Classroom, it is very easy to write a scripts, right? When you compare with the previous slide where there is a cumbersome code, right? The code exists for a very long, a very long length. You can see that this particular page rank, whatever that is being written in a pig Latin script, is merely runs in a few lines and not even in pages, right? That is the advantage of writing a scripting language and a programming language. Programming language is rather very structured approach of writing it. And when you talk about scripts, they are very unstructured way of writing it, and the length of the code is also very less when compared with the other programming languages, right? You may see that hundreds and thousands of lines of code which is being written in um, Java or which is written in C++. They are all examples of a structured programming language, which basically is reduced into a few lines of codes when you talk about scripts, right? That's the reason why many people do not prefer writing scripts, because you will not learn the skill of coding, right? You will lose the skill of coding and you will just resort to easy way of doing things rather than hard way of doing things. So that is the reason why people don't prefer people who do excessive scripting, right? Because it's an easy approach of doing things. Right. Now you can also observe that when you compare Java and Pig Latin, the number of lines of codes which are used, right? In industry, the measurement is the number of lines of codes, right? How many lines of codes do you basically read and write, right? How many lines of codes that does a programmer basically write on a per day basis, right? So this particular instance, what we are trying to look at, is a very important instance basically because the efforts of doing a coding job is drastically reduced um, with respect to the pig Latin scripts, right? You can see observe in this particular slide that the amount of efforts that is required for writing is drastically reduced. So this is how you basically change the way in which the coding happens, right? See, if you see the 1/12, 1/20th of line of code is just reduced to just 6 or 7 lines of codes. So similarly, when you talk about the development time that is required, right, you have a very less development time when compared with the other um, when it is compared with other styles of programming, right? So this is very important in coding basically. So the development time is reduced by 1/16. The performance is on par with the raw Hadoop system, whatever that we are trying to talk about. That is the major change what we can see here with respect to the coding efforts that is required when compared with the other things, right? So similarly, you can see that the pig Latin scripts, whatever that we are trying to talk about, right, takes care of certain internal checks, right? These internal checks are basically the checks which are basically meant for understanding the schema, understanding the data type, right? Understanding several aspects, right? Like internal type checking, right? Efficient physical data flow, right? Exploiting the data reduction aspects. So there are so many things which is supposed to be internally taken care of. So this internal taking care of is done by the pig Latin, which are without an extra coding effort that is required for it. That is another important advantage which you can observe in a big Latin kind of a system, right? When compared with any other systems, right? And also you can see that there is a very systematic way of executing the system level data flows, right? Running the map reduce jobs, right, is very systematic, and there is early partial aggregations and combiners which are used, and sequencing the jobs from a logical or a conceptual level to that of a physical level is very easily taken care of, right? That's another advantage which we can see in case of the in case of the piglet, right? So you don't see the coding to be a very structured coding, but you can observe that the efforts of coding is reduced, and intrinsically whatever that you are supposed to programmatically take care in case of map reduced programming is being easily taken care of um, in case of map reduced programming. So that is the advantage here. So you can see that there are so many things which are easy to do with respect to the programming in Pig Latin, right? That's the advantage here. Okay, so coming to the next important thing, which is the Hive plus HBase, right? How do these two technologies combine together basically react, right? So this is a very important integration between Hive as well as HBase. The reason is because Hive is basically a query language and HBase is basically a real-time environment usage, right? That is, they basically give an access to the database using the HBase query through MapReduce to the people who do not have code for the business analysis. Right? When you basically talk about the HBase, it has got a flexible storage solution where the rows and the entire columnar scheme is dynamically updated, and you need a strong way of querying the resultant from a HBase, right? Because you are talking about data size which are there in petabytes or in zettabytes of data, right? Today, when you are talking about the scenario of IoT, there are billions of devices which are connected in IoT-based systems, and they are basically generating a somewhere around 400 zettabytes of data, right? If you talk about 1 zettabyte of data, it is as good as watching 3,177 movies in Netflix, right? That is the amount of data that we are trying to talk about for 1 zettabyte. Imagine the case of 400 zettabytes. Then the magnitude of the data that we are trying to talk about is very high in today's exposure, and many of them are through social networks, and many of them are through the personalized data schemes which are being generated, and these are basically stored in a database or a data store. So when you are basically storing such a huge amount of data, the one imperative thing which becomes very important is there may be several read operations that may be performed on this kind of a system, and there may be very less amount of write operations that may be performed. So the reasons of running a SQL queries on HBase would be a disaster, basically because they do not intrinsically convert themselves into a MR job. That is the difference between an SQL and a Hive QL. Now, when you talk about a Hive QL has an intrinsic ability to divide themselves as a map reduce jobs. So we have many such things which are basically used to understand, and this integration is a very important integration, right? So this integration gives us how Hive queries and HBase basically interacts. So the interactions can be something like this, right? You may have an existing table which is being stored in a HBase, and HiveQL basically defines the table definitions. So it basically points to some columns, points to some other columns with a different name, and it is basically managing with respect to that. So when you are talking about any kind of HiveQL, the integration is table to column integration, right? So that is how you are basically trying to understand how it basically works. So there are the different ways in which we can basically try to um, understand the way in which the HiveQL as well as this basically behaves, right? So we will basically try to look into the way in which the way in which the system basically works with respect to HiveQL and HBase interactions. Okay, so coming back, we will have interactions something like this. How a columns of the Hive is basically mapped onto the names of the tables in HBase, right? It's very important that you understand that Hive query language is very much similar to that of the syntax what we follow in structured query language, which is SQL, right? You have data types like name, age, sibling, right? All of these data types are basically available in case of Hive. When you talk about HBase, you basically have the deployment structure, and the table behaves in exactly the same way as what we see as full name, age, address, and so on, right? So one on the right hand side, what you see is a columnar description. On what you see on the left hand side of the slide is basically a description of the table definition, which is basically in a syntax similar to that of SQL. So you may also observe that this integration has certain drawbacks. The reason is because one of them is purely on a MapReduce, the other one is tending to behave like a SQL. So the drawbacks which are there here is that it the binary keys and values which are represented in 4 bytes, and they are not supported as a string in case of Hive. Hive basically has an approach of ASCII based approach. It does not use any other kind of approach for dealing with the binary values, right? You may also have compound row keys which are not supported, and you may have multiple key fields which are used in this case. You may also have concatenated binary row keys which are completely unusable because HBase does not use such kind of systems. Filters are done at Hive level instead of being pushed to the region servers. The partitions are supported in this particular way. The data flows is being generated all over the place, right? It can be logged into Apache logs. You can have application logs, MySQL clusters, HBase clusters. So the data flow basically percolates into logs as well as different clusters what you have basically created. So the temporary or the way in which the log file basically moves in the HDFS system is in 2 ways. One is you create a wild log file, which is a common log file across all the technologies under the Hadoop ecosystem. Second is you basically read nightly and transform the formats and dump it into the file system, which is the HDFS. Or you can also get it tailed continuously, pass it into HBase format, insert into the HBase database also. So there are 2 ways of storing the log files. So MySQL data can also be dumped into HDFS, right? As and when we see that there are trends wherein which people have moved away from the normal SQL system to a NoSQL system, right? When such application demands that there should be a conversion from a schema-oriented system to a schema-less oriented system, right? So there will be a specific procedure that will be used for converting it. That procedure is basically the tables which you have in MySQL will be converted into CSV format, and then it will be dumped as a CSV file into HDFS. So when you dump a file into HDFS, it has a similar behavior as what you see in case of flat file based characteristics, right? Way back before even database came into system, we used to call it as a flat file based systems, right? So the other way of looking into it is you use a replicator of a MySQL, which is basically popularly called as tungsten replicator. You basically replicate parse the entire database of MySQL tables and convert it into a HBase format. That is, you are converting a row column method into just a column method format, and finally that is inserted programmatically to a HBase system. So this is how you basically convert MySQL data into HBase. So now after it is being converted, you may either retain the original data or you may basically purge the original data. In most of the cases, it so happens that a backup is retrieved. A backup is, is basically stored for tables which are converted from MySQL system to a HBase system, right? You basically make sure that you convert the data and you keep a backup of the original data as well as the converted data as well, right? So that is how you basically do that. So when you talk about the production basis of HBase, right? Because HBase is supposed to handle huge amount of data, it is basically required that the tables should run in parallel. For the tables to run in parallel, you may have to copy the table and convert that entire system into a MapReduce job. Only then it can run in a parallel fashion, right? Earlier, before this, when we started with Hadoop, we have extensively seen of how a MapReduce jobs are configured, how it basically works, how a read anatomy is there, how a write anatomy is there. We have in detail went through all of these aspects in detail, right? So now what we are basically trying to do is we are trying to make a table which is already sharded into multiple partitions to work in a MapReduce fashion. That is what we are trying to do in this case. So there are several use cases of the HBase, right? You have front-end engineers, you have research engineers, you have got business analysts, right? Today in the entire world, the most demanded job is a data scientist job. People who are experts in data scientists, data analysts are the need of the hour in many of the places, right? And it itself requires an additional skills to be gained apart from the normal academics what you basically go through, right? And if you go through any kind of jobs which are being posted in LinkedIn or any other place, you see a lot of them are data analyst, data engineer, research engineer, right? And data scientist jobs and level 1, level 2, so on, right? So these are jobs which are in very high demand today. But as far as the roles and other responsibilities are concerned, a front-end engineer basically looks at the statistics and he only operates on the dashboard, right? He does not dwell very well into the back-end process of how it is basically being done. Second, when you are talking about a research engineer, the research engineer basically does a ad hoc queries on users to validate some assumptions, generating statistics about the recommendations and qualities, right? A business analyst is another kind of a job whose main objective is to look into the growth activity effectiveness of whatever that was done, maybe an ad campaign or campaigning or whatever it is, then addressing ad hoc queries and stumbling on the behaviors of the different users which are there, and determining the email behavior and the communication pattern between users. So if you take a simple use case of a table in HBase, create an external table, blocked users with so and so, so and so, you may observe that the syntax is very, very common to what we see in case of syntax in SQL, right? But HBase is a special case here, and you know that there is a unique row key that is being mapped to a set of columns, right? Or a set of column families, basically. So that is how it is basically done, right? In case of your normal SQL, you used to create table with so many fields, and then you say primary key as so and so, and you end that query basically. So here also you basically identify that row key. The row key in this particular use case is the user ID. So similarly, I've got several complex tables as well, where the data is either in the integer format or the data is in the binary format, and they are kept as it is in a composite key, or they are manipulated or changed in a different way, right? So now we basically come to the other tools which are there in Hadoop, right? Almost towards the end of this particular module we are, right? And one of the important tools is the Zookeeper, right? Zookeeper is basically a coordination service for the distributed applications. Its main job is to coordinate activities with MapReduce jobs, right? And Yarn, when MapReduce 2.0 came, the Zookeeper had an additional utility, and that additional utility was named by a separate tool called as Ambari, Apache Ambari, right? And this Ambari is basically a tool which is used for administrative purpose, right? They run on the top of all the systems what we are basically aware of, right? So it is basically looking at admin job of resource allocations, right? Privilege, access, authorization, access to different resources. So that is what it is basically looking into. So the Zookeeper is a centralized service for maintaining the configuration information, naming, providing distributed synchronization, and providing group services and so on. So that is the main working of this particular system. Then you have another technology called as Floom. Floom is basically a technology which is used for configuring the streaming data applications. Right? Floom is basically distributed, reliable, available service for efficient collecting, aggregating, and moving of large amount of streaming data into the HDFS system. Right? As you know, that Hadoop is used for streaming data analytics. Right? One of the tools which under the Hadoop which is used here for such services is the Floom. Then you have a technology called Scoop. Scoop is basically a technology which is used for integration of databases and data warehouses with Hadoop, right? If your technology is still dependent on the RDBMS, but you need to fasten up the entire process, then there is only one mechanism. You will need to connect the RDBMS to Hadoop system, right? If you connect to Hadoop system, the connection bridge which is established is through Scoop. Right? Scoop basically is a bridge between the RDBMSs, right? It is a bridge between the RDBMS, the data warehouses, the data marts, whatever that you talk about. It allows and it supports incremental imports. It imports uses the populate table in Hadoop. Exports are used to put the data from Hadoop into a relational database such as SQL Server. Then you have a framework called as OZ, right? This particular framework is basically used to design and schedule workflows, right? It is basically a scheduler, right? And OZ is basically expresses the workflow in a directed acyclic graph, right? And it runs on a Java servlet container containing a Tomcat server into it. and makes use of all the database stores that are running in the workflow instances, right? It basically states the variable within the workflow definition and also manages the Hadoop job, right? MapReduce jobs, Scoop, Pig, and Hive. It basically works with them and basically creates a workflow and data dependency and time dependencies between these aspects. You also can see that the advantage of using Hadoop is you have unlimited amount of storage. You are not using any kind of virtualization, but still, because of the server scaling under a horizontal and vertical scaling modes, you are able to store an enormous amount of data, and there is unlimited amount of data that you can basically store. Second is it's a high speed processing systems. It is used for processing any kind of data which is structural, unstructural, semi-structured, quasi-structured, any kind of data which map onto the domain of research, scientific, real-time applications, any of such kind of things. The disadvantage of using a Hadoop is that the volume, if it is very small, then there is no need for using the Hadoop. The limitation of the data storage is that the physical data blocks of the Java should be 2 to the power of 64, 63, and the block size should be around 64 MB, right? And the maximum size that it can basically address with a node size of 4,000 nodes is 512 yottabyte, right? That is 10 times more than that of a zettabyte. Then you have Hadoop, which can only be used in batch processing. It cannot be used for any other processing at the backend. Hadoop is not used for OLTP kind of process where you have online analytical processing where the users need to interact. There are more writes than reads. Such kind of jobs do not fit into Hadoop based systems. So there are several references which I would like to leave at the end of this particular module, right? You have got Hadoop with enormous amount of references, right? You may just refer to these references and try to build your proficiency around it, right? Then you have got several web references which talks about NoSQL, which talks about Cape theorem, which talks about several things. So, by the way, there is also a lab which is there in MySQL, right? Sorry, MapReduce. You can basically use that lab which is there in AWS server, right? If you go to Amazon, log into AWS Amazon, create a free account with your BMSIT ID, right? AWS basically gives you $100 free of cost, right? That gets credited onto your account. Using a pay-per-use model, you can spawn the Hadoop MapReduce instance on that and try to work out with it. Right? That is how you can basically work with certain things. Okay. So then there are several books which are there. Right. I myself have got somewhere around 20 to 25 ebooks which are related to Hadoop, MongoDB, CouchDB, and so on. Right. These are all books which will basically enhance your knowledge about the topic. Okay, I would like to stop my session for today, right? And before I leave, I would like to mention that there are several online opportunities